Hello everyone, I am your friend Shadab Imam and we are continuing our lecture series on operations research. So today I came up with another variation in transportation problem. So today we are going to see how we can solve a maximization problem in a transportation model. So let us see the question first. The question says that a company manufacturing air coolers has two plants located at Mumbai and Kolkata. So these are two plants, Mumbai and Kolkata. It has 4 showrooms at Ranchi, Delhi, Lucknow and Kanpur. So these are the 4 showrooms at Ranchi, Delhi, Lucknow and Kanpur. The profit per unit in rupees is shown in the table below. So these are the profit per unit. Plan a production to maximize the profit. So in this particular question, our objective is to maximize the profit. So in every problem, what we'll do is we'll see first that our problem is of balanced type or unbalanced type. So here we can see that we have total supply as 200 plus 300 and the total demand as 100, 200, 275 and this is coming as 305. So the total supply is 300 and the demand is 305. So it is an unbalanced problem. Now in order to convert that into balanced problem, I have already added a dummy row with supply 5. Now after adding this dummy row, what we have is the total supply is coming as 305 and the total demand is also coming as 305. So I have already did this. I have already converted into a balanced form 305. Okay. So now after adding this dummy row, we have total supply is equal to total demand and this 0 represent that this will have 0 profit if any allocation come under these cells. So now our objective is to maximize the profit. That means this particular matrix is showing maximization, that is maximization matrix. Now first of all, we need to understand that we have always solved the problems in transportation for minimization. So what we need to do is we need to convert this maximization matrix into minimization form. So how we are going to do this? We are going to do this by we will select the maximum value in this transportation matrix. So we can see that in this transportation profit matrix 130 is the maximum value and we will subtract this value from the maximum value we have. That means for each cell we will find the difference between this maximum value and the value at that particular cell. So for the first cell we can see that the maximum value in the table is 130 and the value in this cell is 90. So we have to do 130 minus 90. So this will come as 40. 130 minus 90. Similarly for second cell 130 minus 90. This will also come as 40. For the third cell, we have 130 minus 100 because 100 is the value in this particular cell. So 130 minus 100, this will come as 30. 130 minus 110, this will come as 20. 130 minus 50, this will come as 80. 130 minus 70, this will come as 60. 130 minus 130, this will come as 0. 130 minus 85, this will come as 45. And 130 minus 0 is 130. So all these values are 130 and we need to make sure that whenever we have an unbalanced type of problem, we will always add the dummy row or a dummy column first, then only we will convert the maximization problem into minimization. Otherwise our problem will be not correct, our solution will be not correct. So whenever we are converting maximization into minimization, we need to make sure that if our problem is of unbalanced type, first we need to convert it into balanced type, then convert maximization matrix into minimization. So here we have converted this into minimization form. So this is minimization matrix, and now we will start solving with this matrix. Now we know that the problem of transportation is solved in two parts. First is to find the basic feasible solution, and the second is to check for optimality. So first we will find the basic feasible solution and we'll use Vogel's approximation method to find the values. So this is the minimization matrix we have found out here, and by applying Vogel's approximation method we need to calculate the penalties for each row and each column. And the penalty is the difference between minimum value and the next minimum value in that particular row or column. So we'll start with this column. Minimum value is 40, next minimum is 80, so the difference is 40. And here minimum is 40, next minimum is 60, the difference is 20. Here minimum is 0, next minimum is 30, so the difference here is 30. Here minimum is 20, second minimum is 45, the difference is 25. Now moving on to the column, minimum is 20, next minimum is 30, and the difference here is 10. Now here minimum is 0, next minimum is 45, and the penalty here will be 45. Here minimum is 130, next minimum is also 130, so here the penalty is 0. Now as we can see that among these the maximum penalty is 45, so we will select this row, and in this particular row we will select the minimum value of this cell. So we can see that 0 is the minimum value, so we will try to allocate as much as possible in this particular cell. So we can see that we have 100 as a supply and 100 as demand. That means we can apply or we can allocate 100 units here, and after this will become 0 and no more allocation can be done here. Similarly this will also become 0 and no more allocation can be done in this column. So again we need to calculate the penalties here. So again we will be calculating the penalties for each row and each column. So let us calculate it. Minimum is 40, next minimum is 130, so the difference is 90. Here again 40 and 130, so the difference is 90. Okay, this has been fulfilled. Here 30, 20 and 130, so the difference is 110. For column we have minimum value as 20, next minimum is 40, so the difference is 20. This has been fulfilled, and for this minimum is 130, next minimum is also 130, so the difference will be 0 here. Now we can see that 110 is the maximum value here, so we will try to allocate in this column, and we can see that the minimum value of cell in this column is 20, so we will try to allocate as much as here. So as we can see, the demand is 30 and the supply is 200, so we will allocate 30 here. That means this will be 0 and no more allocation can be done in this particular column, and the remaining value here is 170 because 30 has been allocated here. So now again we will calculate the values or penalties. So as the column does not change, the penalty will remain same and the column row penalty will change. So As you can see, this is 40 minus 40 is 0, and this is 130 minus 130 is 0. Now we have two values, 90 and 90, so we can select any one of them. So I am selecting this value. So we can see that we have 40 and 130. So 40 is the minimum value, so we will try to allocate here. So out of 170 I can allocate 75. That means 75 has been allocated here, and this has been reduced to 95. Now once this has been allocated, no more allocation can be done in this row. Now we have only single column left, and by default we need to allocate in this particular cell. So we have 95 can be allocated here, and we have 5 can be allocated here. So this will become 0, this will become 0, and this will also become 0. Now we have a basic feasible solution here. So let us write the basic feasible solution in the next column. So this will be 75, this will be 95, this will be 30, this will be 100, and this will be 5. Now to find the optimality of this basic feasible solution, we need to have exactly m plus n minus 1 number of allocations, or independent allocations as you would say. So m is 3, n is 4, 3 plus 4 7 minus 1 is 6. So we need to have 6 allocations, but at present we have 1 2 3 4 5. We have 5 allocations. We need one more cell, which is a potential cell for independent allocation. So what we'll do is we will select a cell with minimum cost or minimum value in the cell, and make sure that this does not form loop. If this forms loop, we will select any other cell. So if I allocate here, I can see that it is not forming loop. That means I can definitely allocate here. So epsilon I have allocated here. Epsilon means null value, that means it has a 0 value, and now we have exactly m plus n minus 1 number of independent allocations. So now we will check optimality, and for that we will use modified distribution method, or we can call it MODI method, and for that we will calculate certain variables u1, u2, u3, v1, v2, v3, v4. So now for basic cell or allocated cell, we will have Cij is equals to ui plus vj. So by this we will calculate the value of all the variables, and for that I need to take any one of the variable as 0. So I have taken u1 as 0. Now 40 is equals to 0 plus what, or I can say 0 plus what equals to 40. So I know that 0 plus 40 is 40. Similarly 0 plus what equals to 40, so this will again be 40. Now 0 plus what equal to 30, so 0 plus 30 is 30. 0 plus what equal to 20, so 0 plus 20 is 20. Now 30 plus what equal to 0, so 30 plus minus 30 will be 0, so this will be minus 30. 40 plus what equal to 130, so 40 plus 90 equal to 130. So we have find out all the values of u's and v's. Now we need to find out the values at non-basic cell, or we can say empty cells, and in this empty cell we need to find out the value of Cij minus of ui plus vj. So this is the value we need to find out at empty cell or non-basic cell. So here we can see that 80 minus of minus 30 plus 40, so this will be 10. 80 minus 10 is plus 70. Here 60 minus of minus 30 plus 40, that means 60 minus 10 is plus 50. Here we have 45 minus of minus 30 plus 20, 45 minus 10 is plus 35. Here 130 minus of 90 minus 40, so this will be 130 minus 130 is 0. Similarly 130 minus 90 plus 30, so we will have 130 minus 120 is plus 1. 130 minus of 90 plus 20, that means 130 minus 110, this will be 10, sorry, this will be plus 10, this will be plus 20. Now as we can see that at non-basic cell we have all the values coming as 0 or positive, that means we cannot improve this solution, and this is considered to be an optimal solution here, and we need to find out the value of z for this particular value. So z, and we need to calculate the z maximum. So to calculate z maximum, what we will do here, we will take these quantities, multiply by the values in the original matrix. So in the original matrix the profit function is given as 90, so we will do 75 multiply by 90, not 40, because this is because we need to find the maximization value, not minimization. If I do 75 into 40, I will get the minimization value. So in order to get the maximum value, what I'll do is the number of quantities, that is 75, multiply by the value or the profit in the profit matrix. So here is the profit matrix for maximization. So this will be 40 into 90 into 75, 90 into 75 plus again 90 into 95, 90 into 95. Again we have this epsilon, means this has 0 value, so 30 into 0 is 100 into 0 is 0, so I am not calculating this. Here it is 30 into 110 plus we have 100 into 130, 100 into 130. Here we have 5 into 0. Okay, in original matrix this is dummy and this shows 0 profit. So after calculating this, we will get the value as 31600. So this is the Zmax or maximum profit that can be obtained, and for this maximum profit, this is the optimal allocation. And one thing more we can see here, that one of the values in the non-basic cell is coming as 0, and in the previous lecture we have seen the case of alternate optima. This is 0, that means if I allocate 1 unit here, then it will definitely form a loop, and by allocating here our cost will neither increase nor decrease. That means it will have no effect on the value of z, and we will have a different combination of allocation for the same value of z. So we can say that it has one more solution, or it is a case of multiple solution for maximization also. So here this is the problem for maximization. If you like the lecture, please share the lecture. Have a nice day. Thank you.